Hi everyone. I asked you to complete the true false in your packet, and we're going to go over that in class tomorrow. So I just wanted to give you a couple, wrap up what we were talking about as I introduced the idea of logs. And there are some general facts to know. So first of all, reminder that you always want to think about what that definition means. So if I give you log base 2 of 8, just think of it as what power is 2 raised to that gives you 8? 2 to what power gives you 8? Now, I suggested that an algebraic way to look at it would be like, if you can't see that, maybe you could set the expression equal to x and use that idea. 2 to what power gives you 8? So 2 to what power gives you 8? And here then, there's either thinking involved or making the bases the same, right? So we could make 8 2 cubed. And so x would be 3. Now let's go back to that definition. Does that work? 2 to what power gives me 8? 2 to the 3 power gives me 8. So log base 2 of 8 is 3. All right, so let's talk some facts you got to know. The common log, the log that we use as just like our x or our x squared, our common log, is a log that has a base 10. And so actually we just write it like that. We actually don't write the base. So when the base is not there, you have to know it's a base 10, and that's the common log, okay? Your calculator log button will only work on the common log. So go ahead and look at your calculator right now. And if you go down the first column, you're going to see that 1, 2, 3, 4, 5, the 6th button says log on it. So go ahead and press that and maybe put in log 100, okay? So you have to think really carefully about that. That's asking you 10 to what power gives you 100. So hopefully you get the answer too. Okay, so when we're using our calculator, we can only use a common log, and we're going to talk about that. So for now, we're doing these by hand. All right, now I got to get really tricky on you. I'm introducing something really powerful and really helpful, and that's called the natural log. Okay, so we have the common log that's a base 10, and the natural log has a base of, I want you to think really hard about that new number that we introduced this week. Natural logs have a base of e, okay? And this one is used quite frequently, so we're going to really work on this one a lot. Now, the thing about this log is that we gave it its own name, okay? Log base e means a log with a base of e. And so there's just this itsy bitsy other thing. We're not going to write it like that, okay? We gave it its own cool name for the natural log, and that's ln. Yeah, I know, a cursive L and then N and then E. Like if I write ln-E, that's log base E of E. If I write ln2, that's really log base E of 2, but we're going to write it like this. This is how you're going to see it. So that means it's the natural log. So now grab your calculator, and if you look right under the log button, you're going to see ln. You've been looking at that button for years, and you never knew what it was. So we're going to be talking about this in class as well. Okay, so just to review, the common log is a log with a base of 10. So this is how it would be written, and this is how you have to think about it. The natural log, ln is the natural log. It has a base of e, so you're going to see ln x, and you just have to think that it means log base e of x. Okay? We're going to be working with it tomorrow, so you can ask any questions you might have. All right, let's review. So log base 7 of the cubed root of 1/7. So 7 to what power gives me the cubed root of 1/7? All right, so this might be a great time to set it equal to x and write it using the definition. So 7 to what power? 7 to what power is going to give me the cubed root of 1/7? Okay, all right, so I might play around here. I might say, okay, to make these look the same, first of all, I need 7 to the negative 1. That might be step 1. Step 2 then would be to get rid of the root, and so I would make that 7 to the negative 1 to the 1/3. And so then I could make it 7 to the negative 1/3. So in this case, x would be negative 1/3. So 7 raised to the negative 1/3 gives me the cubed root of 1/7. All right, you try. 7 log base 749. Stuck. Now, I want to go back to order of operations. Order of operations says that we always use our exponents. We do exponents, grouping symbols, exponents first. So this is my exponent. Well, what's log base 7 of 49? 7 to what power gives you 49? Well, 2. So this is just 7 to the 2, which is 49. Do you notice anything? Do you wonder anything? Well, you might notice that these are the same. You might also notice that the result of that was this. And that is true. If you raise any number to a log of the same base, your result is going to be that 49, where that 49 is, okay? All right, ln(e). So this is basically saying e to what power gives you e. So this is actually a cool one. This would be 1, right? E to what power, if you think about it. Let's write it like this so you can see it. E to what power gives me e? 1. But again, we got to get used to seeing ln. All right, ln(1). We did these with log the other day. E to what power gives you 1? Same property applies. E to the 0 gives me 1, so ln(1) is equal to 0. All right, so let's just wrap up. Let's look at the special things that happened and must-knows. So through our lesson in class the other day and now, we look at our log and we use our definition. Log base b of b will always equal 1 if these two are exactly the same. So if the example was log base 7 of 7, 7 to what power gives you 7? And again, that would be 1. Log base b of 1 is going to be equal to 0. And that's because if I give you log base 5 of 1, 5 to what power gives you 1? Right? That's what the log means. 5 to what power gives me 1? So that would be 0. So you're going to see these a lot. You're going to want to get used to them. All right, that last one I just went over, b raised to the log base b of x will always equal x. So 7 log base 7 of 49 is 49. All right, change of base, making the bases the same. If you have two expressions where the bases are exactly the same raised to powers, then the powers are equal. So x equals 5. All right, ln(e) we just said was 1, and ln(1) we said was 0. I'm going to add one more. It was the last thing we did in class. If I give you log base 5 of negative 3, remember that the exponential function has an asymptote here, and a log is the inverse of that. So that means that the log function has a vertical asymptote instead of a horizontal asymptote here, which means that the log graph always has to be greater than 0. So this is not possible. It's not within the domain of the log function. So log any base to a negative number can't exist. All right, guys, that's it for today. We're going to be practicing and working with logs for the next week and a half or so. If you have any questions, this is the time you're going to have to get into see me, okay? Have a great day.